Now let's say you have a tennis ball with a mass of 2 kg and it is moving at a velocity of 5 meters per second to the right or towards the wall. Say it's moving this way towards towards a stationary wall. This is my stationary wall here. Okay, and the tennis ball hits the wall. Let me draw my stationary wall. Okay, it hits the wall and bounces back, and now it is moving at a velocity of 4 meters per second to the left or away from the wall. Now, what do you think is going to happen to the momentum of the ball after it hits the wall? Will it stay the same or will it change? Let's see. The initial momentum was the mass multiplied by the velocity. What was our mass? It was 2 kg. Multiply the velocity, it was 5. And this is going to give us what? 10 kilograms meters per second. And the direction to the right or towards the wall. And then let's see what was our momentum after it hits the wall. So we're going to say our final momentum is given by the mass multiplied by the velocity. Let me just put this down here. Our mass was what? It didn't change, 2 kg. And then now our velocity. Notice that after the tennis ball hits the wall, it changed the direction. So now we must express that in our calculations. And what do we say? -4. Okay? And then this is going to give us 8 meters. No, sorry about that. Our final momentum is going to be 8 kilograms meters per second to the left. Now this negative, I express it in terms of direction. That's why I didn't write -8. I only wrote 8 kilograms meters per second to the left. Okay, so now keep in mind that this 8 is negative. So clearly, by looking at these calculations, we can tell that there was a change in momentum. And in physics, whenever we talk about change, we know we use the symbol delta. And in this case, when we say there was a change in momentum, we are saying there was a change in momentum. And this symbol is symbolized by the final minus the initial. So we are looking at the final momentum minus the initial momentum. So the change in momentum is given by the final momentum minus the initial momentum. So now we can expand this further by saying this is going to be the mass multiplied by the final velocity minus the mass of the object multiplied by the initial velocity. And since we have the same mass, we can say that we can factor out the mass, and we're gonna have mass open bracket. If we factor out mass here, we're gonna be left with the final velocity minus, and if we factor out the mass here, we're gonna remain with the initial velocity. So in simple terms, we can say that the final momentum is given by the mass multiplied by the delta V. Sorry about that. Delta V. This delta V stands for the final minus the initial velocity. So this is the formula we're going to use to calculate the change in momentum. Okay, so if we were to calculate the change in momentum for our last example, which is this one, we can say the change in momentum is equals to, we had the final momentum, which was -8. This negative is for the direction, and then minus our initial momentum, which was 10. And then the answer gives us -18 kilograms meters per second. Or you can use this formula here. Let me change the color. If you have to use that formula, you're going to say delta P, or the change in momentum, equals to the mass multiplied by the final velocity minus the initial velocity. And this is going to give us, what is our mass? It was 2 kg, multiply the final velocity, it was -4, the initial velocity, it was 5. So this minus is from the formula. Our initial velocity was 5. Then we simplify that, we're gonna have 2 multiplied by -4 minus 5, we're gonna have -9, and this times this, we're gonna have -18 kilograms meters per second. Now, what is the direction of the change in momentum? We look at the symbol here, our sign here. Our sign is negative, so it means our final momentum, the direction of our final momentum is what? Is to the left. So be careful with the direction. When you start, choose a sign that will represent the left, and a sign that will represent the right. So in this case, our right is represented by the positive sign, and then our left is represented by our negative sign. That's why every time we have a negative sign, we know that the direction has changed to the left, and every time we have a positive sign, we know that the direction is going to the right. Okay, so but now look at this. There's something else. When the ball hits the wall exerts a force. Let me use the black one. Let's say this is our wall. This is our wall. When the ball hits the wall, this wall exerts a force on the ball. This is according to Newton's first law of motion. and this force is exerted for a certain period of time, okay, before the ball goes back. Now, when we talk about force, we usually think about one guy, one genius. And who's the genius? Newton. What does Newton say? Newton's second law in terms of momentum says the net resultant force, let me write it down, the net resultant force acting on an object is equal to the rate of change in momentum. He says that the net resultant force acting on an object is equal to the rate of change in momentum. If we are to express this in a formula, we're going to say the net resultant force equal to the, when we talk about the rate, we know we're talking about time of change in momentum. This is our change in momentum. So we are saying when the ball hits the wall exerted a force on the ball, which caused the change in momentum. So the force was exerted for a certain period of time. When this happens, we call it an impulse. So impulse refers to the change in momentum of an object when a force is applied for a certain period of time. Okay, so in simple terms, we say impulse is a result of a force acting on an object for a certain period of time. When this happens, it results into an impulse. But when we look at our formula, we can deduce that our change in momentum equals to this multiplied by this. We're going to have the change in momentum equals to the force net multiplied by the delta t, or the time. So what this means, it means my impulse equals to my change in momentum. So whenever in the exam they ask you to calculate the impulse, you know you will use the formula F net is equals to over delta t. This is your impulse. Why is this my impulse and not in my change in momentum? We said impulse refers to the change in momentum of an object when a force is applied on an object for a certain amount of time. And what is the change in momentum? A change in momentum, we are looking at the final and the initial momentum of an object. We are not necessarily looking at how the change occurred or what caused the change. So you'll see that when we do calculations. Let's just do one example. So let's solve this question. You can pause and try to do it on your own to see if we're going to get the same answers. So the question says, a 5 kg model rocket is launched from rest and reaches a velocity of 12 meters per second in 3 seconds. This is the result of the upward force of the exhaust gases. Then the first question says, calculate the change in momentum of the rocket. The second question says, calculate the net force experienced by the rocket. Okay? So now, let's go to the first question. Remember what I always say, always write what you are given. Sorry about that. Always write what you are given. What am I given? A 5 kg. I know that this is my mass. We have a mass of 5 kg. Rocket is launched from rest. What is this? This is my initial velocity. And it's going to be 0 because it was from rest, meters per second. It was launched from rest and reaches a velocity of 12 meters per second. So my V final is going to be 12 meters per second. In what? In 3 seconds. So I know that my time is going to be 3 seconds. This is the result of the upward force of the exhaust gases, meaning the direction is upwards. Okay, now the first question says, calculate the change in momentum of the rocket. And we said that to calculate the change in momentum, the formula we use is change in momentum equals to the mass multiplied by the final velocity minus the initial velocity. What is our mass? This is our mass. We substitute that. Multiplied by, what is our final velocity? This is our final velocity. It's 12 minus. What is our initial velocity? This is our initial velocity. Is 0. Then we get our momentum is what? 5 into 12 minus 0 is 12. So our change in momentum is going to be 5 multiplied by 12, which gives me 60 kilograms meters per second upwards. Okay, we go to the second question. It says, calculate the net force experienced by the rocket. How do we calculate the net force? We know that the formula is net force equal to the change in momentum over delta T. So now we are looking for the net force. So we're going to say, what is our change in momentum? It's 60 over, what is our time? The question says, we go back to our scenario, a 5 kg model rocket is launched from rest and reaches a velocity of, in what? In 3 seconds. So our delta T is 3. So we're going to have 60 divided by 3, which is going to give us 20. And what is the SI unit for force? Newton upwards. Remember, force is a vector. Upwards. Let me just put this. So this is basically how you use the formulas. So in conclusion, I would like to write something so that you don't get confused during questions. In conclusion, we say to calculate the momentum, we use the formula. The momentum is equal to the mass multiplied by the velocity, and is measured in kilograms meters per second, and the direction. To calculate the change in momentum, we use the formula. Change in momentum is equal to it's going to be the mass of the object multiplied by the final velocity minus the initial velocity. This is the formula that we use, and the answer will be in kilograms meters per second. Now, to calculate the impulse, we're going to use the formula. Change in momentum equals to the force net, or the net force, sorry, the net force multiplied by delta T. Okay, so we use this one here because now the momentum changed due to a force acting on the object over a certain period of time. Okay, so that's it for our video today. If you like the video, drop a comment and like it, and also don't forget to subscribe to our channel. Thank you.